Okay, so my name is Phillip Vorce, and I use PID Control, or I built a program in Python that simulates navigating a path using PID Control. And for those of you who know what feedback control is, I'm sorry for this very, very quick definition for the people who don't. So what is PID Control? It stands for proportional, integral, and derivative. And these are the three terms in the mathematical formula that act upon a system that you want controlled or automated. That describe how the system will behave when it is controlled. And the basic idea is that you input where the desired state you want the system to be in, and sensors on that system read its current state. And the difference between those two, that is the desired state versus the current state, is what is referred to as the error. And the controller seeks to make that error zero so that where you are and where you want to be are identical. And each of these three terms does so in such a way that they work together, minimize each other's faults, and arrive at the desired state quickly and accurately. And some examples of where you might find PID today would be in industrial furnaces where you need to maintain a certain temperature, or missile flight control where you need the payload to hit its target. So why PID? The simple answer is that I think automation is really cool, and this was my first exposure to the field. I got my degree in mechanical engineering last year, and the class that taught this course was easily my favorite class in the entire curriculum. And not only that, it was a senior level course, which meant I was really ready to be done with school. So this meant, this gave me something to do that I found both enjoyable and technically challenging. And now I'm going to move on to actually talking about the project, and starting with tool selection. First thing is NumPy. I started using this early on because the way you use arrays reminded me a lot of MATLAB, which I was already familiar with, and I used it as a security blanket. Later on, I kept it because I learned that arrays in NumPy are faster and are more compact than Python lists, so didn't have to refactor my code. Second thing was Pygame. This came at the suggestion of my mentor on day one of the mentorship program. It gave me a way to show how PID control works in real time, which I wanted, and it also allowed me to create a frame or window very easily and a GUI in that frame. So with that in mind, I'm going to show a very quick demo. And here is the window itself. We've got each of the coefficients listed and their current values on the right. The text box can change those values, but I'm just going to leave them as a default to save time, and I know they work. So I'm going to start it off, and here you can see the system going. I'm going to show these sensors down here. Hopefully in the back you can see it. It's these white squares here. They're detecting that the system is on path in gray. When it hits yellow, it's going to check each frame if the system is heading in the path. And if it's not, a correction is made because there's error. And this is just going to head in a circle forever and ever, so I'm going to move on. But getting around the corner is really when the PID is in action. So going back. So next thing I wanted to talk about was project evolution. I was brand new to Pygame. I'd never used it before. So getting just a moving background was an accomplishment. It'll show here in a second. So that was the first major accomplishment. I had plans to make a randomly generated road, but that proved to be like a headache to debug because it was inconsistent, among other reasons. Second thing is, so I ended up scrapping a lot of that code, but I was getting the hang of Pygame. And so I built this test area to work in, and I made the player character. And I wanted to show the direction of where the character was heading, and I was using the keyboard at this point. But I found in Pygame they actually have a transform function specifically for rotating an image. And here you can see it going, and it didn't work so well. So I had to come up with my own solution. The next major accomplishment was actually building the circular path that I just demoed a second ago. And here I am testing out the sensors for the first time. And there were more issues. So it took a few iterations to get that working. And so now I'm going to move on to what I learned. I could spend my entire presentation on just this slide alone, but I'm going to cover just a few of the big ones, the first being classes. Okay. Originally when I started this, I knew about classes, but I did not understand them. And after reading documentation, checking out Stack Overflow, and following guides, they just kind of clicked, and now I want to use them everywhere. They just really make it easy to organize my code. The second thing is project expectations. This is just as important, but kind of abstract. The idea that the project will not go the way that you think it will. And that sounds like a no-brainer when I say it out loud, but I thought I would spend a lot of time on getting PID Control working, but really I spent about 80% of my time doing, getting Pygames set up to the way that I needed it to. And I'm going to stop there. I also had academic versus application. I learned all this in school, and applying it was very difficult compared to homework problems in school. And then I also had a future work slide that I'm not going to get to, but thank you.